Hello. Today we're going to continue talking about adding and subtracting rational expressions, and we're on our notes on page 5. So if you want to get that page out, the last video we had, we finished question number 5, and now we're going to do numbers 6 through 9. So the first example, we see that we have unlike denominators, and you can't subtract two fractions when their denominators are different from each other. So what we're going to have to do first is factor the denominator, or any denominator that we see. So this first denominator, x minus 2, can't be factored. This second one has a GCF of x, so let's take it out, and we're going to be left with x minus 2. We'll just lightly cross that out. So now we're taking a look at this denominator, which has an x minus 2, and this one has an x minus 2. But this one is missing the x. So if we multiply the top and bottom fraction by an x, we're going to get x times x minus 2 in both denominators. So let's mark that down. Our LCD here is this one called x times x minus 2. Close up the parentheses. So what's our next step? Well, we've already got this as our common denominator. So what we can do is just take this denominator, and this is missing an x. So if it's missing an x, we have to multiply the top by x, open up parentheses, and the bottom by x, open up parentheses, because we can do the same multiplication to both the top and bottom and keep it an equivalent fraction. So now we can see that our denominators are the same. They're both x times x minus 2. Our next step is to distribute this x through the parentheses in the numerator. So this is going to say x squared plus 3x, and then you're going to have a minus 10 here. So I'm just going to pull this down a little bit, and the first numerator, x squared plus 3x distributed. And then we're going to subtract from that this 10, and we can put it all over this LCD that we've just named up here, x times x minus 2. Now we would be all done with this problem if it weren't for the fact that this numerator can be factored. Don't distribute this x through here because we want it factored completely just in case we can cancel something out. So there are factors of negative 10 that add up to 3. They're positive 5 and negative 2. So this one is factorable, so let's factor it. X plus 5 times x minus 2. Lightly cross that out, and now you can see that we have an x minus 2 on the top and an x minus 2 on the bottom, and those are common factors. And remember, factors can cancel. Terms can't, but the factors can. So let's just cancel out this x minus 2 with this x minus 2. Oops, this x minus 2, sorry, that's part of the LCD. Oops. Okay, and then what are we left with? We're left with an x plus 5 on the top. The x minus 2 canceled, and we're left with just an x on the bottom. This x and this x cannot cancel out because this is a term. Remember, terms cannot cancel. And this is a term because it's got a plus sign next to it. Terms cannot cancel. So we are done with this problem. Over here on number 7. We have two denominators that aren't the same, so we're going to have to factor them first. That's our first step when we're adding and subtracting fractions, is to factor the denominators, sorry. So x squared minus 36, that's the difference of two perfect squares. X plus 6 times x minus 6. Lightly cross that out. This denominator has a GCF of x. So let's take that x out of there, and we're going to be left with x plus 6. And now we're going to look across this whole set of denominators here. and see what we have. We're going to do something called build our LCD. And our LCD contains every unique factor. So here's the x plus 6. We have an x plus 6 over here, so this factor, this LCD, is going to contain an x plus 6. It has to because it appears here. The LCD is also going to contain an x minus 6. This LCD is going to contain an x because of that x right there. And you can put the parentheses around if you want to, but you don't have to. And then we would write this x plus 6 again, or we would write this down in the LCD, but we've already written it once, so we don't have to write this again. You only have to write it one time if it's already appearing somewhere else. So here's our LCD. So we're going to take a look at that. Maybe we'll circle it so we don't confuse it like before. And now let's look at this denominator. It's got an x plus 6, an x minus 6, which it has here, but it is missing this x. So in order to get this to match this LCD, you're going to have to multiply it by x. So let's put it out in the front. So we'll put this x here, and if you multiply the bottom by x, you have to multiply the top by x also. In this fraction, we have an x, we have an x plus 6, but what is this one missing? This fraction, excuse me, this fractional, let's lightly cross this out because we've already factored it. This fraction, this denominator is missing this x minus 6 right here. So what you're going to have to do is multiply the top and bottom by x minus 6. So there's the top and there's the bottom by x minus 6. Now you can see this fraction really says 2x all over x times x plus 6 times x minus 6. And this again is subtraction. Be careful of subtraction. Always look at this as a negative 1. This negative 1 gets multiplied by the x and by the negative 6. So what we're going to do is we're going to put this whole two fractions into 1. We have a 2x, we have a negative 1 times x, and a negative negative 6. So let's write that down. Here's our 2x from here. Negative 1 times x is negative x. Negative negative 6 is a positive 6. All over our LCD, which we said was x plus 6 times x minus 6 times x. This x can go in the front or back. It really doesn't matter. Now we have a couple of like terms that we can combine. 2x minus x, 2x minus 1x is just x. So I'll combine those like terms into this x. And what do we have now? We have x plus 6 in the top. X plus 6 all over x plus 6 times x minus 6 times x. Oops, I don't need that. If you want to surround this numerator with parentheses, that's fine, and it might help you see that this x plus 6, this whole binomial, cancels out with this whole binomial because it's a factor. It can cancel factor. So when you cancel something out and it's completely gone, you're going to put a 1 in the top. And now what we're left with is a 1 in the top. And in the bottom we have an x minus 6 that's left over and an x that's left over. And you can leave it like that if you want, or you can put the x in the front if you want. They're both correct. That's correct. That's correct. Or if you want to distribute this, this can say 1 over x squared minus 6x. It really doesn't matter. They're all correct. So there are many ways to write that correct answer. The next one, number 8, has a denominator that says x squared minus 49. That's the difference of two perfect squares again. So let's factor this into x plus 7, x minus 7. This one is a trinomial. It has a negative 35, and there are factors of negative 35 that add up to negative 2. What are the factors of negative 35 that add up to 2? I think it's -7 and +2 or +5. So let's factor this one into x minus 7 times x plus 5. After we get the denominators completely factored, let's write out our LCD. And our LCD will have all of these factors, but if it appears twice, you only have to write it once. So our LCD will have this x plus 7 in it. It will have this x minus 7 in it. You don't have to write this again. We already wrote it once. And then it'll have the x plus 5. So this one has 3 factors in the LCD. And now we take a look at this denominator, and which one is it missing? It's missing the x plus 5. So let's multiply the top by x plus 5 and the bottom by x plus 5. Looking at this denominator, we've got the x minus 7, the x plus 5. Which one is this missing? This denominator is missing an x plus 7, so the top gets multiplied by x plus 7. The bottom gets multiplied by x plus 7. And now both of these fractions have common denominators, which means all we have to do is combine these numerators into one big numerator. And at the same time, what we're going to do is we're going to distribute the 7 into this set of parentheses. So we have 7x plus 35. Now this negative, here's the danger. I put a lot of subtraction in here because this is where people make mistakes. If you want to just make this little minus wander over here to the 6, it's like distributing a -6. Because of this subtraction, it's like a -6 into the x and into the 7. So -6 times x is -6x. -6 times +7 is -42. And that's all over our LCD, which is x plus 7 times x minus 7 times x plus 5. Now our job is to combine like terms. It looks like 7x minus 6x are like terms. When you put those two together, you're going to get x. So let's cross out 7x minus 6x. That's equal to 1x. And then we have positive 35 minus 42. And if you want to pull out your calculator, you can. Or maybe you know you just subtract 42 minus 35 and make it negative. Well, that turns into positive 35 minus 42 is a -7. So now all of our like terms are combined. If you want to put the parentheses around the x minus 7, that's great, because then you see the x minus 7 in the top, the x minus 7 in the bottom, they'll cancel down. And on the top you have to put a 1 because there's nothing left. So you have a 1 on the top, and on the bottom what hasn't canceled? The x plus 7 hasn't, and neither has the x plus 5. And you're done with that problem. On to the last question. This last question has 2 subtractions in it. My goodness, everything is subtraction in this one. Probably because it's the trickiest. So 2x minus 1, not factorable. There's no GCF. It's not any kind of thing that we can factor, and neither is 2x plus 1. But this is the difference of 2 perfect squares. 4x squared minus 1 will factor into 2x plus 1 times 2x minus 1. And now that all the denominators are factored completely, let's write out our LCD. Our LCD has a 2x minus 1 in it from this denominator. It has a 2x plus 1 from this denominator. And coming over to this denominator, we've already written the 2x plus 1. Don't write it again. And we've got 2x minus 1 here. Don't write that again. So what we have is this fraction is missing the 2x plus 1. So let's multiply the top by 2x plus 1. And let's put parentheses around here and multiply the bottom by 2x plus 1. This second fraction is missing the 2x minus 1. So let's multiply the top by 2x minus 1 and the bottom by 2x minus 1. This fraction already has an LCD, so we don't have to do anything to it. First fraction, let's take the 2 and distribute it through the parentheses. 2 times 2x is equal to 4x. 2 times 1 is equal to 2, positive 2. Now we have a subtraction. Remember that negative, you sneak it over next to that 1, and it's really a negative 1 that's distributed into these parentheses. So negative 1 times 2x is a negative 2x. Negative 1 times negative 1 is positive 1. And then we have this negative here, which is going to be next to our 2, so we have a minus 2. And there's the whole 3 numerators all together as 1, and the denominator just has a 2x plus 1 times 2x minus 1. They can be written in any order. It doesn't have to be in this order. You can switch them around. Let's combine like terms. 4x minus 2x is equal to 2x. 2 plus 1 is 3. 3 minus 2 is 1, positive 1, so all those combine into a positive 1. I'm going to put parentheses around this because then you can see this 2x plus 1 and this 2x plus 1 will cancel out. Put a 1 on top because our final answer has a 1 on top, all over a 2x minus 1 on the bottom. And that is the end of this video. Have a great night. I'll see you tomorrow. We'll get lots of practice on this in class.